rebooted in like the last 3 weeks.
Yeah,
Yeah.
This one's been rebooted a bunch of times.
I rebooted it over the weekend. It kept freezing up when I tried grepping something. It would just freeze and I couldn't make it do anything. It was weird. I tried grepping, I can't remember what it was. It would just freeze up after I installed my keyboard or keylogger. It was probably because it was messing up with because that's a USB keyboard technically.
Maybe something funny was going there.
Yeah, it probably crashed.
Yeah.
Are you still going to try to run IRQ handlers in an infinite loop?
Oh yeah, that's right. I was going to try that today. Except I want to push the button on this computer over here that I've been using for this stuff. My volunteer. And my volunteer isn't starting up today.
Oh, you're giving me the finger.
So you've
Volunteer's like,
succeeded.
I'm done, Seth. I quit.
Does that mean that you've
Yeah, it actually has
succeeded?
intelligence. That's impressive. Has the intelligence to say, I'm just not going to do anything. I refuse to follow the human's commands.
Skynet.
Maybe,
It
yeah.
lives.
That's actually,
You know, they actually have a British communications satellite network called Skynet,
Do they?
I believe.
That's ominous.
I mean, I can check for sure.
That's ominous. They're just asking for it now.
Skynet satellite. Skynet is a family of military communications satellites now operated by Astrium Services on behalf of the UK Ministry of Defence.
They're defense
Provide
satellites.
strategic communications
Astrium
services to
Services.
3 branches of the British Armed Forces.
you know, Astrium Services just sounds like a
Yeah.
malevolent corporation, like Umbrella Corporation from Resident Evil. It just sounds really malevolent.
Right?
Now, to be perfectly fair,
And it was rebranded.
Astrium Services.
this picture of them launching a Skynet satellite is from 1969, which predates the movie, so they did have the name first.
Yeah,
Okay.
and if you go back to that first page, they say they rebranded it to, I couldn't see what it said.
Oh, did they?
Yeah, and very bottom, October 12th. Or 2012.
Well, satellites
The
are operated
organization
by...
was,
Rebranded Austrium Services.
Well, that's Paradigm Secure Communications. I mean, that means it's still... I know the Skynet operated by... Yes, it's operated by Astrium Services. And I guess it used to be operated by Paradigm
Oh,
Secure
okay.
Communications. I think it's still called Skynet.
Isn't that the corporation that Bruce Wayne owns?
No.
Astrium Communications?
That's Wayne Industries.
Oh, okay. Same difference.
I went and forgot to start my volunteer in the correct operating system, so I'll do that real quick here.
Do you care if we work on our keyloggers like during your 101 classes?
No, that's fine. You can do
Okay.
that.
Seth, I was curious about something. When I was here on the weekends, either by myself or with Gus and Brian, there was like, the computers would sometimes just like restart and then shut down and restart with a different operating system by themselves. Were you doing something over the weekend?
No, actually, that has nothing to do with me at all.
It was a ghost.
Okay. I think this place is haunted because I've heard a few like just loud banging noises and doors shutting outside while there was nobody else up here.
His name is George. He was an IT guy that fell off the 3rd floor.
Really?
Yeah.
I didn't know that was weird.
Oh, poor Jorge.
That was his name. He just went by George. He wanted to assimilate.
Hey,
Yeah.
I installed Encrypt on one of the computers. I was wondering if I was alright.
Yeah, go for it.
I figured I'd encrypt what I was doing.
Yeah. Okay, there that goes. Okay, so I got notes now. I wanted to try this. I meant to do this a while ago, and for some reason, it never ended up happening. I wanted to make a kernel module with an infinite loop inside an interrupt handler, and I know why I wanted that victim now, or that victim, volunteer. Same thing. That was my security class terminology for the programs that we're supposed to exploit. Anyway, so this is volunteer is up. If it goes up, I'm not sure it will. Oh, I'm past it. Yeah, it's working this time. Okay. This one actually has the right type of keyboard, and so I can cause a single interrupt. I could put an interrupt handler on a network card or something for this one, but if we put an infinite loop inside that one, we're going to be running like a whole bunch of infinite loops. And that's probably worse, but I don't know. It's not quite what the intended effect here. I wanted something where I can walk over and start it, and then it starts going. It still doesn't seem to be starting up, so it might be that we're on this one anyway. We'll start writing the software for it. Either that one will appear or not. This one's R1C4. Okay. Okay, C4 is an explosive.
When in doubt, C4.
There's a lot more powerful than the movies make it out to be too. Like a brick of it could take out one floor of this building. Probably take out the rest of the building depending on the floor you do it on.
Okay, so I probably have like an Mnet or something to start from over here. Got lots of frozen fractal stuff on this thing as usual. Remember we had this kernel crypto example. That's the last thing we used R1C4 for. Okay. We'll go ahead and copy the Mnet demo from Isoptra because that has a interrupt handler, I think, to, dash lowercase r.
Yeah.
No space left. Oh, the hard drive is full.
So like frozen fractals.
When in doubt, C4.
C4 also burns very hot, so if you
Okay.
have water with it, be very careful.
Oh, it's got webcam videos. I think I already posted these because they're 901. If I never didn't post them, they're pretty old. That's probably why it's full. Maybe. Or maybe I was playing with the screen recorder. Anyway, we got 257 megabytes now. That's enough. Because we only need like 100K. Oh, maybe I tried to cover the kernel. I don't know. Need a CP. There we go. Okay. Actually, I have the keyboard interrupt handler right here. Okay, so we got this interrupt handler. And so the question we're trying to answer this morning is what happens if we go into an infinite loop while we're in the interrupt handler? Okay, and we don't want to sleep in our loop. Sleep is cedes control to something else, and we don't want to do that. We want to maintain control. And so we'll go ahead and do that. We can just start it doing something. It doesn't really, well, it doesn't even really matter. I mean, that's an infinite loop right there. And do nothing as fast as you can. And so we'll put some note for loop ended. Okay. And so now we have a,
Won't that be in the loop?
no, because I put a semicolon at the end of the
Oh,
loop.
okay.
Okay. So now we have like probably a press any key to crash the computer kind of script. This one over here with my PS2 keyboard is continuing to not work. And so what we might have to do is use a different interrupt. And
Does that machine have a PS2 port? Because I
No.
have it in a box.
no, it doesn't.
Um,
It's an AMD machine. I guess I could start up another of the Intel machines. We have plenty of them. I'm reluctant to go breaking them all. Let's see, timer. This goes off not too often. SATA, let's see if we use a hard drive. Radeon there. The Radeon's probably not really increasing, 1127. Yeah, look at that. We're not seeing anything on the Radeon interrupt there at all. And if I go over and move the cursor or something, I'm betting we're going to see a change. Because then it's going to actually have to tell the video card to do something. Okay, let's see. No, but actually that's fine anyway. Because you see what did change is the OHCI USB 2. And I'm not going to be able to create one interrupt with the mouse necessarily, although maybe if I carefully click the mouse without moving it, we might actually have created one. So I want to leave that display up there. So I grab, what was that one? USB 2. Okay, 214. So we got two. Probably they click down and up or something. USB pulls, but it pulls fast. So that'll work fine. We just have to set this thing up to monitor interrupt 23. Okay, instantly I haven't touched the keyboard. Oh, we can actually use the USB keyboard there, actually. Okay, anyway, 23 I think is what we just said, isn't it? Okay. So let's make that again. That's inserted. Oh, maybe it's built in that. Go to make file, yeah, it did. Let's make KIH. Warning, function declaration isn't a prototype.
These things really generate a lot of annoying errors and warnings sometimes.
Yeah, that one's actually getting errored on us. And so it's talking about this one right here, I think, that it's not a prototype. And it's true, it's not. We can make a function prototype. I'm not
Oh, you have to
entirely
give it
certain.
something. That's why it's yelling at you. I had that problem.
You have to give it something?
Yeah, you have to pass it something.
You just
Oh.
have to put a void in there, right?
Or void or a 0 or something. You just it
Oh.
wants something.
Yeah, I could want that. That makes sense.
Oh, there you go.
Okay. Good catch. Okay. Did you build it?
You know?
Well, it didn't have any fatal errors.
Oh, that was from ModPro.
Why did my keyboard stop? What did ModPro actually say?
There it goes.
Oh, yeah. Not found, but it's right here. Oh, in Spot. There we go. Okay. So, computer is happy. Here's a real-time display that you can see is changing a little bit. Not very much. And so I'm going to go over and click the mouse and see what happens. Okay, is it still updating? Yeah. Does it work by move mouse? No. The cursor does not move. Let's go over here, and yeah, we still seem okay. And actually, top isn't showing like a high CPU usage, although it's taking a weirdly long time to start. Like, that's definitely not how long it took to start last time. So, well, that's interesting. I'm assuming that we can't just SSH and at R1C4 anymore, because probably the SSH is not going to respond. I wonder if this is because I went and moved the mouse. Okay, so we got this interrupt handler. And our interrupt handlers are kind of a top priority. Preemptible interrupt handlers are possible. Linux never used to have them. So let me go ahead and check if I can. I didn't spell preemptible even slightly right. In fact, it doesn't have a second P in it. But there, I found it. Okay, so there's an RT preempt patch to convert Linux into a fully preemptible kernel, and stuff about preempting them. So it's something that can happen. I don't know if the kernel over there is compiled with preemptible or interrupt handlers or not. They were doing some work to make the kernel fully preemptible, and so that's why you're seeing results here around last few years talking about that issue. Preemptible kernel is kind of a good thing in a way, because then if your kernel is busy doing something and you want to do something else, it can be interrupted. But an interrupt handler is a hard place to put preemption, because it's got to deal with the device, and usually there's some kind of time-critical task that has to be completed. And so this infinite loop, it seems to be that it's not getting preempted, probably. The movement on here is just from the computer this terminal is running on, not the one that the SSH session is logged into. So I'd say if you give it an interrupt handler in there, you lock it up tight. Now, I should probably go restart this, and it has 3 cores in this machine. It's possible that if, notice it was still updating the display after I clicked the mouse. It might be that when I clicked the mouse, it created 2 threads, used up 2 of the 3 CPUs, and kept updating the display. We can tell in a minute, but I suspect that's how it goes, yeah.
Because you weren't feeding it any values, is it filling the RAM full of null values?
Well, no, the for loop didn't generate any data,
Mhm.
so it shouldn't be filling memory.
And how come it eventually locked it?
And starting Windows.
Because it was too busy.
Okay.
It was kind of like, if, suppose there's a dealership, car dealership, and there's 3 salesmen standing outside, and you want to interrupt all activity in a dealership because you want to walk straight into the counter, parts counter, and buy something at the overpriced prices for some reason. And you don't want to be hassled by any salesman. So you send 3 friends, and they each go to the salesman and they say, I'd like to buy a car today. Then you've occupied all 3 salesmen with some task that they can't possibly leave.
Okay.
And so then until your friends leave and either fail to buy a car or do so, they're all occupied.
So we overwhelm the interrupt handler.
Well, kind of. We just gave it something to do. I suspect with a single core machine, we would have locked it up right away because we would have taken out the 1 core with the 1 loop. I should have picked that a little bit more before I actually moved the mouse. Oh, it's okay. We can kill it again in a minute. I want to talk about other ways to kill computers today involving memory. So this is a good precursor. So you close my terminal here. Okay. Incidentally, minor note on the topic of terminals. When you set up there's a bunch of different terminals, and sometimes it can be important. So Xterm is like an old classic terminal for the X windowing system, and I've used it before. It's a good terminal. It's a solid terminal. It doesn't have any exciting features whatsoever, but it does everything that you really need in a terminal. GNOME terminal. This one's one that a lot of people like because it's got modern features. See, if I go to do an Xterm here, this actually starts an Xterm, and I right-click on the Xterm, it does some highlighting. And if I wanted a menu bar to go with my Xterm, the answer is no, you can't. It's an Xterm. GNOME terminal adds, a window and menu bar and that kind of stuff, so which makes it easy to change the font. See, the fonts are actually defined in kind of a square term here by, well, let's go ahead and, didn't change. Maybe that's one I already had. Okay, I'm not sure why it's not changing my font here for me. Probably because I have it set in a different way. But anyway, the fonts are set in a confusing way in Xterm, and if you look at it for a while, you can figure out how to set them up. For example, I have an Xterm set to automatically set the font to 9 by 15 and background black and foreground white. And so when I type Xterm on Nimrod, that's what happens. So you can set all of those things, and that works fine. Okay, here's the funny thing about terminals, though. There's a few more out there: RxVT, KDE terminal, XFCE terminal. There's a few extras, but the terminal has an identifier that it actually sends along to the machine you're connecting to, and the machine you're connecting to uses it to know how to address your particular terminal. And if you use a terminal that sends it an identifier that it doesn't understand, programs will work oddly sometimes. So it's just kind of a random gotcha. Xterm is usually an absolutely safe choice, but if you're using something else like RxVT, you log into something and it's like unknown terminal type, and then it doesn't do what you want. So that's what it means when you see it here. Okay. And that was a tangent. Okay, let's go ahead and insert this once more. And everything's fine, everything's happy. Our display works. I'm going to go very carefully click the mouse, and then we'll poke in at it for a moment.
So interrupt 23 is the mouse.
On that machine. If I took the mouse plug and plugged it into a different port, it may well change. Oh man, I locked it.
What's the command to view that?
This here?
Well, the interrupts.
Oh, the interrupt. You just, they're in a file.
So it's interrupt 23.
Is it a proc file?
Yeah, proc interrupts.
Oh, okay, that makes sense.
And so yeah, it depends. So USB 1 and USB 2 are the major USB controllers on this machine. A single USB controller can run more than one USB port, and it can be linked to a USB root hub, which can have more devices on it. Yeah.
So USB.
So the keyboard's on USB 1, or is on interrupt 22, which is USB 1 on this one, right?
Yeah, probably. Here's how you check. So I'm not going to touch the mouse. I'm going to, let's grab USB. Okay, so without touching the mouse, I do this again, and you can see the interrupt count increased here for the number of interrupts that have happened on USB 2. So my guess is that's where the keyboard is. It can't be on the other one. None of the numbers. That changed. Uh-oh. If they're both changing, you know what? Given the giant number of interrupts that have happened on 22, I'm guessing this is the webcam.
Oh.
I forgot about that. And this one down here is increasing a little bit. Keyboards usually increase them a little bit. And so see that 380 is slowly going up, and the webcam one is just going through the roof. Now I'm going to move the mouse. Move, run again. What do we see? I would guess the mouse is on USB 1, because I did not see a dramatic increase on USB 2. Well, maybe. Let's move it for a little longer. Move. So this should be generating quite a few, but it's not like thousands of interrupts. It's like, you know. Oh yeah, look at that. It's on USB 1, or USB 2, just like the keyboard. See how much that increased? Just from playing with the mouse.
So because it's on USB, you're missing some, right? Because it pulls.
Well, it can do multiple letters in one polling, potentially.
So you're missing some data then, because it's
Well-
pulling. Or will it just dump everything it has out once it gets it?
Actually, the bigger problem isn't necessarily going to be the number of interrupts, but your NB function.
Oh, okay.
Because NB is getting data from your PS2 device, which is very easy to address because it's just on a PS2 bus.
But I mean, in your module itself, like every time you click, you're not getting every click. You're missing some, right?
You might be. The polling rate is pretty high. Gamers say it's not high enough, and so they plug them into the PS2 port. But they're right. I mean, if you pushed like 3 keys at exactly the same time, you wouldn't get 3 interrupts on USB. You get 1, because they'd all come through at the same time. So when you get your data from the keyboard, it may have more than one letter to report, more than one scan code.
Oh, okay.
But how you get the data from it's going to change a little bit too, because you got to go through a USB bus.
Yeah. So you can't use the same module and just feed it into a queue?
You might be able to make a module that adapts and does either.
Okay.
What I would have to do is, before it registers for an interrupt, just do some digging and figure out where the keyboard is.
Okay. So you
You can
could
just poll, see if there's an interrupt 1. If there is, attach to it. Otherwise, look for the USB.
You want the thing that LSUSB does, really. LSUSB scans your USB bus, and so there's a list of gadgets that are attached. And
That tells you which bus on the far left.
oh yeah, awesome.
Is that the
That
interrupt?
would have been easier. Oh, well, it's not the interrupt, but when we did proc interrupts, we can see which interrupt each of these are, USB 1 and 2.
Oh, okay.
Yeah. Yeah, you can combine that and get it. So that does clarify everything that we just discovered, and yeah, we're right. Bus 2 does indeed have the Dell Computer Corporation optical 5-button wheel mouse and the Tang Top Technology Company LTD HID keyboard, which I think is my little gadget. And the other one, the Dell Computer Corp keyboard, is sitting over there by the Elmo, and it's still plugged in. So yeah, you can go through, and both these USB keyboards will generate interrupts on the same one, and they both work. You can plug in a bunch of keyboards these days. It used to be the case, but you can now. Now the other thing about the USB, see these little USB root hubs? Oh, this is interesting. It looks like USB 1 has a 2.0 root hub, and USB 2 has a 1.1 root hub. So there may actually be USB 1 ports on it. Okay, so you got all these devices attached to these USB buses. The way the USB system works, you can take a USB bus and run it out to a USB hub, which will let you put more devices on that same USB bus. And you haven't increased your number of USB buses. You still got 2 of them reporting here on the motherboard. But you can attach more and more gadgets to it. And there's an upper limit to how many USB gadgets you can put on a USB bus, but it's a high limit. Like, you have problems with actually getting data to all of these things first before you run into the hard limit. So that's part of the way the USB infrastructure works. And I'm betting that this computer has USB 2 and USB 1 ports on it, and probably it matters to some extent. I'm glad I got the webcam on a USB 2 port. LSPCI, I'll show you a little bit about the hardware that's on the board. And so we should be able to see at some point the USB controller right here, NVIDIA MCP51. And it looks like they are both the same, so I don't know what we're looking at with this USB 1.1 hub. It
Well,
could
it
be
could just be the hub itself is only supports up to 1.1.
Yeah, it could be, because the motherboard manufacturer, when they're soldering all this stuff together, you know, they can put in an NVIDIA chipset that has USB 2 support, 2 buses of USB 2, and then they can attach one of them to a USB 1.1 hub, and then solder that to all the ports on the back of the computer. That's a valid option. And yeah, it's kind of like, well, why don't they just run a full standard throughout? But it's more expensive to do that. I've seen expensive motherboards that have, these days, that have USB 3 and USB 2. And it's because they soldered on a big USB 2 hub in order to put on a whole bunch of USB ports. Because it doesn't really matter which one you plug in, stuff like, you know, in printer or whatever too. Yep.
My board has, I think it was a couple 3s on it.
Yeah. Yeah, which you probably reserve for like a thumb drive or whatever you like to transfer stuff fast from.
Depends. Actually, I think on the ones in the back, I have my mouse and keyboard plugged into them just for kicks and giggles.
There's not to really, unless you need it for something else. But you can move stuff easily. Okay, well this is thoroughly locked up. I don't know if I maybe moved the mouse slightly when I pushed the button or not. And so I can't answer the question of whether or not it would have survived if we generated exactly 2 interrupts. But now you know a lot about USB or interrupt handlers with infinite loops. So actually it's kind of cool in a way. What we did is we made a kernel module where if you touch the mouse, it freezes the system. And you could make that for any other gadget that has an interrupt in the same way. So you could be like, okay, well I'm going to make a kernel module, and you put it in, and as soon as I use a network card, it freezes up the machine. That'll take them a while to figure out, maybe.
Depends on if they're constantly connected to the internet. If they are, then they're screwed. It'll just, every time it's in there.
Right. It'd be better if you had some kind of random chance on it. Like every time you move the mouse, each interrupt gives you a 1 in 1,000 chance of starting an infinite loop. Because that way it would take a little longer for anybody to notice, you know.
Oh, you could just put in like a random number generator, and if you hit the right numbers, you can have it pop in.
Yeah, yeah, exactly. It's sort of like the old trick where you put a piece of clear tape over the optical sensor on one of these mice, and then with the right mouse, well, some mice will do this, some won't, it'll act like a ball mouse that was full of hair. Just like kind of skips sometimes and sometimes not. Yeah. Oh yeah, so I wanted to talk about memory and memory leaks. So let's go kill the computer again. Where's our volunteer?
Yeah, I did this on my computer one time.
Yeah.
Where I just allocate a bunch
We're
of
still locked up, isn't it?
Oh yeah. I'll go reboot it because the other volunteer is showing a blank screen. I don't know what's wrong with the other volunteer. I don't feel like I broke it because last time I used it, it was working fine.
The computer I've been working on hard crashed this morning, so maybe it's just
Yeah, these things are all going to need re-imaged after this semester. They need updated anyway.
2 semesters of operating systems,
Yeah.
kind of rough on them.
Don't forget the security as well.
Yeah, we did that too. Although that was mostly inside the virtual machine.
Yeah.
True. But never doubt possibilities.
Oh, I need to go push that. I can never remember this. I don't know why.
Can't you tell it to only boot in one option with options?
Well, if I go change Grub's configuration, yeah, I could do that.
Just change the default to what you need it to be.
I thought it had options in it where you could just say only on Linux.
As far as I know, Grub just reads read-only on the ext3 partition that it reads stuff out of. So I don't think so. Oh, I was supposed to advance that kernel rolling project one more, and it doesn't work. That's fine. We'll just talk about memory today. And I guess I broke it. Let's rebooting. It feels weird though. I'll see if it boots into Windows.
And now I have a different idea. Could you make it to where it's Linux that it boots into automatically and you have to change it to Windows, like for Linux?
Yeah, I just have to go and change the grub options.
I feel like that would annoy a lot of people though.
Yeah, it would.
Almost
Yeah, it would
nobody
annoy
uses that computer.
It would annoy people that don't know how to fix it, like people in CS 108.
Yeah. It's like, where's Alice?
Yeah. Well, Alice is on the Linux side on that.
Is it?
Yeah, it is.
Oh, that's kind of cool.
I think it's on there anyway. It surely should be if it's not.
I didn't really
Okay,
like Alice that much.
I'll be taking it next semester.
I'm sorry, Kyle.
That sucks.
That's not that bad.
Wait, you're taking Alice?
I have a choice between CS 101, CS 110, or CS 108, and I decided 108 was best because I'll actually learn a language in it.
110 is 108.
Yeah, 110 doesn't exist anymore. Okay, so I'm gonna make a program that leaks memory.
Yes, lied to me.
And it's gonna be a little bit harder than it looks in some ways. I need STD-lib here too. Okay, so one way to make a program that leaks memory, just go ahead and use malloc. Malloc allocates memory. That's a kilobyte. That's a megabyte. And we'll put it in leaked memory. And I'll make leaked memory a void star. So it's a pointer to that. Okay, so we just allocated a megabyte. And so now we want to start a loop, an infinite loop, where we just go ahead and reallocate some memory here. Okay. And I should put some kind of note to show you that it's continuing here.
I thought malloc didn't work in the kernel.
This isn't in the kernel.
Sorry, I
Printf works too.
missed that.
I'll go ahead and put the address here. Inside LX. I think that's a long text. It should be right.
You spelled memory wrong.
Yeah, I can. Yeah.
You just
It
dropped
really
it in.
matters in the print statement portion.
Yeah. Well, doesn't everything matter?
Not really, no.
Nothing really matters.
Okay.
Thank you, Rush.
Okay. Long unsigned int has type void star. Oh, that's fine. Okay. So you can see we're allocating memory in
There's a
different
lot of memory.
spots. And let's go over to that machine, R1C4. That's the right machine, right? I think so. And hit top. So you can see our used memory up here. For some reason, the swap partition isn't online on this machine, which is okay. But the memory is actually not all used up. We got 8 gigabytes there, and we're using 1.3. So everything is happy. And you know, if we did this, you know, it works fine. Computer's good. Okay. If we look at our program here, notice that it did actually stop after a while. This is because the operating system has told it that it's not allowed to have any more memory. And so malloc is waiting for more memory to become available for that program. But of course, we look over here at our display, we have plenty of memory. So here's what it's doing. We asked for all of this memory. I can't even control C, so we'll kill it. -9 ADA. Okay, well, it doesn't want to go away here. I seem to have locked up my terminal there. But anyway, so the program thoroughly died, but the system was fine. So what it's doing there, if we look at our leaked memory.c, we haven't actually stored anything in this memory. So there's no reason to actually allocate a page here. So what the operating system's doing is telling this program, okay, you can use this memory, but it's not actually allocating the memory to it unless it uses it for something. This makes a lot of sense, because then this kind of leak isn't a problem. Okay, so let's make a function that fills it. Okay. Okay, so this is going to fill out memory up. Oh, we need a size here. Okay, so for Nothing, size is greater than 0, size minus. Okay, so we need to just put something at that location. I'm going to go ahead and pretend the memory is a character. Okay, so now that it's a pretend character, we can just say cmem at position size equals 0. Okay, now this whole size thing here, we're going to be 1 too high. We can do size -1. We have to do that a lot of times. We'll just do it right there. So the thing is, if size is 10, all of our characters are going to be numbered 0 through 9. And characters 1 byte, so characters are right size to go through here. So we need to subtract 1 there first. Okay. So, fill and I feel like my fingers just don't want to hit the right keys today, which is a little weird. Let's try this. Okay, spray something in program, yeah. Like I said, I think just want to try keys today.
You need one of those wireless keyboards.
Oh, that work better? Would I remember to put the size here then? It's probably it would, because they generate RF and RF waves. People say they create cancer, but actually the tumor is a mathematical coprocessor that develops. You gain the ARM processor from the phone over time.
So you become stronger if you eat the processor?
Oh yeah, definitely.
All right.
So now you can see our memory usage is on the way up. So now we have an actual problem. And it's actually not going to even take that long before you fill up 8 gigabytes. Writing this on a high-end computer doesn't help you because then you allocate the memory faster. So, yeah, low or high.
Can we run this on Isoptra?
No.
All you gotta do to make it worse is make a few threads doing the same thing.
Yeah, that's true. We could have started a bunch of processes doing it. Now, we might end up running into a limit of how fast the operating system can allocate the memory. It's probably got at least some threading locks. Okay, we're almost there. This one doesn't have any swap partition to fill up either. Oh, look at that. It's going back down. What could possibly have happened? It got killed. So, what happened is, eventually the operating system said, well, if we give this program any more memory and it tries to use it, we're going to have a problem. And so it refused to give the memory in a little bit more fatal manner for the program. But overall, the operating system is going to protect us here pretty thoroughly. Okay, now there is one consequence that will happen to this. So if I did it on Isoptra, and I won't.
You should.
Yeah, everybody would dislike it. Okay. So you can see if we look at top, we've got about 25 gigabytes of stuff that's in main memory right now. And we have a swap partition here that has 618 used, 6.3. Okay, so when we go use up all the memory, it's going to end up pushing everything from the active part of this into swap, which is going to make it all really slow. And then when we close this thing down, it's going to stay there, and so then everybody's programs that they're running are going to run slow until they get back into main memory. And that's actually the main consequence of it. So it's not that dramatic a breakage at all. At least not for the standards of this class. No web browser. Okay, that's the wrong class. Well, this is like an old class that I taught back in ancient history, like yesterday. Okay, so yeah, so as mentioned, you have to actually use the memory before you can use it up. So I wanted to show you a couple ways that are commonly generate memory leaks. So here's one common pattern. Okay, so suppose we have some kind of function. I'll make this one. Leak demos.c. Because everything always goes fine. Okay, so I'll have some sort of function here. say Malik something. And so then in here you can say something like Malik, and you get something, some kind of size, and some kind of variable equals. Okay, so then you go ahead and use it, and then at the end you just say like return, you know, something else. I don't know. There's position 1 or 0. There we go. Okay, so this one allocates memory, and then it loses it, right? Because we're not deallocating it. We haven't called free anywhere, and so it's just playing a function that has a memory leak, assuming it's actually used that array for something. In which case it'll leak real memory. Otherwise it just leaks addresses for the program, which can eventually make the program crash. Incidentally, that computer booted fine in Windows, so yeah. Okay, so that's a common pattern. Here's another common pattern. Okay. Okay, there's a lot of functions that do this, and so what they do is Malik something big area. Bitch. Wasn't even that close. Okay, and they save this somewhere. And I don't know what it is. I guess this has to return a pointer, doesn't it? Okay. It's our area. Oh, I think I already named it. I don't know why I even bothered with that part. Okay, so you calculate something.
You've got a semicolon.
Oh, it'll make my editor act weird. Okay. And, dude, I really can't type today. Okay. There's another common pattern. So when you return this area, the user of the function has to free the area. Otherwise, it's gone. This is the main two ways that leaks form. And it's possible that you can do it the way we did leak memory too, where you have some kind of loop, and the loop runs malloc and makes an area and fills it, and then moves on to the next one. That can happen too. Okay, so that's how you get to those things. Oh, let's run Valgrind real quick. This will be fun.
There's no variable called mySize. It won't run, or it won't compile.
Well, yeah, Valgrind isn't installed either. I was just going to run it on the earlier one, leak memory.
Oh, okay.
Because it'll run on that. Okay, so that'll be in here in a few minutes. And it doesn't, I mean, those computers, oh wait, does it have enough space? 93 megabytes? Yeah, they were good. Okay, so we'll go ahead and run that. Now, the usual way to fight these kind of memory leaks is using garbage collection like Java or Python or whatever. And there's a number of ways garbage collecting can be done now. And it doesn't, you know, some of them work better than others. Okay, I'm going to run Valgrind. Okay, so that's what my program prints, I think. Let's go ahead and Control-C to stop the program. And so Valgrind says here, let's see, heap summary, definitely lost. And indirectly lost, nothing, possibly lost. Yeah, that's probably what was in it when I hit Control-C. Still reachable. There's a little bit still reachable. So yeah, rerun with leak check equals full to see details of leaked memory. So it's found it, and let's go ahead and do this. First of all, let's compile with debug symbols. UCC memory.c-g. Okay, we got debug symbols here. Terminal code equals full. Okay. So let's let it run for a minute here. It's run slow in Valgrind, so I'm going to Control-C and I'll let it finish. Okay, so it's got our definitely, oh, wait a minute. I ran leak check equals full. Oh, no I didn't. I gave A out that parameter. Okay, I'll run for a minute, and there we go. So now we've got a longer summary. So you can see exactly where it is. And so they're saying, well, you lost some in main at leak.memory.c line 12, which is kind of cool, and line 15. All that stuff is definitely lost. So that tells us where memory leaks are coming from. It doesn't exactly fix them, but yeah, that's kind of cool. Okay, reachable blocks, those are the point I was having, we could show that if we wanted to. Okay, so Valgrind is a tool to find out what's leaking exactly. So, as far as garbage collection, the standard method is a tracing garbage collector. And so this is what Java and such use. And so tracing garbage collection, the idea is if you have an object and you can still reach it, then it should still remain allocated. And if you can't reach it by any way in the program, then you might as well go ahead and dispose of it. Okay, kind of a simple rule, but in terms of analysis, it does get a little tricky. If we look at our leaf examples, demos, that's it. Okay, the first case up there, it's not that hard actually in this case, because you finish this and it goes out of scope and you're done. This case here, you get to the end and you return area. Well, it depends what exactly happened with area. And so if we say down here something like, instar area equals return pointer, and we go ahead and call it, and then we say if, I don't know, something that's not known until this time. User says something, area equals 0. Hey look, we just used it for something else. We lost the reference. Kind of. Because we got a block here. And so it depends. If we said area equals 0, we're fine. If we said int area equals 0, well, no, we're not. But anyway, so we changed our reference on area. And so now it went away if this was true. And so there's no way to know at compile time necessarily if we can go ahead and free it at this point or not. Because we don't know what's going to be said there. You know, it might get used later. And so this does mandate some kind of process that runs around in the background, keeping track of whether or not things are reachable. And so that extra process, the garbage collector does use some resources. Okay, here's an alternative. This has been considered a number of times, reference counting. And so the idea here is that for each object, you have some kind of reference count, and this indicates how many times it's that you have a reference referring to it. Same kind of thing as we do with files. Now the file, we increase the reference count when it's being used. Yeah?
Question, what if the garbage collector, what if that has memory leaks in it?
Well, then that's bad.
Yeah, that would be unfortunate.
Yeah.
Because the garbage collector is not going to be collecting garbage on, well, maybe it is collecting it on itself. I don't see any good reason it can't. There might be a practical reason it can't, but here in the ivory tower, I think it can.
Meta collection.
So the reference counting, you just count how many references there are, and then you decrement it. So you can insert code for this stuff if you wanted to. Basically, you just come down here, and every time you change something involving a pointer that involved dynamic memory allocation on a heap, then you go ahead and insert code for reference checking. Yeah, I guess that would work. But there are some issues. For one thing, you might have a parallel program here. And if you've got a parallel program, you might have more than one thread that are using objects. And so when you change one of these reference counts, if you've got any kind of object that's being used by both of them, it has to be thread safe. And so you end up having to lock the reference count while any other thread is using something. So if some thread has some function where it generates a reference to it, like reference something is whatever, and then goes ahead and uses it for read-only access, and then stops using it, you have to adjust the reference count in a thread-safe manner every single time. So imagine like a for loop where all the iterations are independent, and you said so with OpenMP or something, and you come down and they all manipulate the same array, and the first thing you do is make a reference to their section of the array. Well, then you've got to have a thread-safe reference count happening for each thread. And so they get to do that change one at a time. And so that could be kind of a problem in a performance sense. Here's another issue. So suppose you got some sort of data structure like this. Well, now you can't ever deallocate it because the reference count is not 0 on A, B, or C. Oh, sorry, you can't see that. It's a circular linked list. A, B, and C, they point to the next one. So there some method has to be made to figure out, well, wait a minute. These refer to each other, so the reference count is not 0, but yet the whole thing can get deallocated. So there's issues that come up on this, and that's probably why it's not really the leading solution. So that's why with the tracing garbage collection, you start out with your collection of references you have in your program, and for each of those, see if you can reach some area of memory, and if you can't, then it can go away. Because that solves this problem quite nicely. You don't have any reference in the program that reaches A, B, or C, so they can all be deallocated. So that works. Okay, so yeah, thread safety and reference count manipulation, yeah. So then you have all the memory and time overhead, and all this stuff can work, it just tends to be a little slower. Okay, so let's look at another strategy here, static analysis. Here's how static analysis works. You have the compiler go through here, and it says, okay, area is return pointer. If user says something, we're changing it. Okay, free area, okay. Continuing. At compile time. So it's compiled in. So it doesn't really add a lot of time on the program part. It just has the compiler do what would otherwise be something the user has to, the programmer has to do. It's kind of a cool idea, eh?
Well, in that case, you could almost make computers that could program themselves.
Yeah, yeah.
Almost, not quite, but.
Yeah, so static analysis is basically just have the computer figure out where to insert free for you. And it's an up-and-coming idea. See, part of the problem is our example there was nice and simple, but when you get into an actual program, it can be a little bit less clear where exactly free goes. And I'm not going to pull up an example in the next 18 minutes of that because I spent so much time crashing that computer. But it's something where you got to think about that a little bit. Now, LLVM can do that, so it's actually out there, and Apple is using it. So this is a totally valid technique. And I want to talk about LLVM for just a minute. So I want to talk about systems and that kind of stuff. Okay. So LLVM, I want to draw a picture here. And I'll move that in a moment, and maybe it'll come out. We'll see. I'll draw it over here on the lighter side. Okay, so the whole GCC compiler suite, you got front ends for languages, and there's a lot of them. Okay, I'm going to stop now so I don't run out of space. And these all feed into an intermediate representation. And the intermediate representation is in the form of a tree. And then these things get fed into the optimizer. And then after that, they get fed out to different backends that'll generate for different processors. Okay, so that's how how the GCC suite works, and maybe you can see, maybe not. Okay, so here's what LLVM does. You got another front end here called Clang, and Clang can take C, C++, Objective-C, and I feel like there's one more here that I can't remember at the moment.
Swift.
Swift, yeah. Okay, and so all of this stuff feeds into Clang, and it can optionally go there, or it can go kind of directly to LLVM. It stands for Low Level Virtual Machine, but that's actually an outdated expansion of that acronym. And then this thing makes it for whatever it makes it for. I don't know if they have other backends in x86-64, probably, but I'm not sure what they are, so I won't list them. Okay, and I mentioned this path. No, that's wrong.
I think they have an ARM backend.
Okay, I'll put that there because I believe you. Okay, so there you go. Now, this path here does in fact exist. And so you can take that route through the whole compiler world if you want to, and there can be advantages for doing that. Or, the other way, if you want to use LLVM and you want it to do the static analysis and put in the memory stuff for you, but you want to write in Go. You can feed Go into this intermediate representation, and the whole path is there. It's not a well-established path, so you'll have to do some reading on Google if you really want to use it, but, it's possible. Okay, I'm going to put the camera there and look at it for a moment. Yeah, there we go. Okay, perfect. Now we'll go back over here. I'm actually paying attention to the camera today. How weird is that? Okay, so yeah, LLVM. It has a dragon symbol, which is like new looking, and it's written in C++. What do you know? So I guess they figured that's the best language, people that write these things. Okay, use a different intermediate language. Okay, so it's got some advantages. Let's talk about, well, yeah, we'll get through, no, let's talk about Apple real quick. Apple likes to use it since 2001. They figure the static analysis thing is the way to go. And so that's an indication of its increasing maturity. If we go back to the page I just left, where Wikipedia explains it, notice that the initial release was in 2003, and it's still under active development. It took until 2001 before Apple wanted everybody turning on the other thing. I don't know if they have history here, but anyway. Yeah.
Well, I was right. It said ARM.
Oh, you did?
Yeah.
Awesome. Cool. Well, you're fast at reading stuff as it scrolls by. I was just spastically running the scroll wheel and talking. Good job. Okay, so the LLVM used for Apple. So it's kind of mature. So these systems come together, including the operating system and everything else. And well, kernel and everything else. So we talk about the PS4 for a moment. It uses Orbis OS, which is a modified FreeBSD. FreeBSD itself, they have a demon mascot that I guess runs around in the background wearing shoes. And it's a derivative of the old BSD, Berkeley Standard Distribution. It's been around for a long time. It's POSIX compliant. It's the kind of thing where if I went over to one of these machines and installed FreeBSD, I could probably make it look enough like Linux that it would fool you for like 30 seconds until you try to do something with the kernel. Because it uses the same stack of stuff on top of it, as in X Windows and any of the Linux windowing environments. And in fact, it can even run Linux binaries. So it could even fool somebody if they were in like, I don't know, some kind of software development class and they compiled something on a software and ran it on a FreeBSD machine in here. So you can substitute it in pretty easily, but it does have a completely different kernel. It's popular enough that NVIDIA actually releases a binary driver for their video cards for it. So you can go to NVIDIA.com and download your driver for GeForce 9 series, it's the current one, and it'll work. So that's kind of neat. Linux games, yeah, they probably work, I don't know. Haven't tried it. Okay, so that's what it is. So they adapted this thing for the PlayStation 4. And they put a browser into the system, web browser into the system based on WebKit. WebKit is a set of libraries for making web browsers, basically. And some quite popular web browsers are based on WebKit. Safari and Google Chrome. Opera, which used to cost money. Anyway, but it's basically an application programming, like a library, where you can write web browsers. It's a layout engine. Okay, released under BSD license, most of the browser engine. The BSD license there is significant because since it's released under a BSD license, which says you can take this the source code, but even if it kills all your children, you cannot sue us. As opposed to the Linux license, which says you can take the source code, but if you modify it, you have to release the changes as source code for free under this license. So BSD is easy to take into a commercial product, which is probably why they picked Orbis instead of Linux for PS4, because now they don't have to release any of their changes. They can keep them all secret. Okay, so they got a WebKit-based browser, same kind of thing. Take WebKit, make a browser, put it into the product, charge a lot of money for it. It has support for OpenGL. OpenGL, Open Graphics Library, is the premier cross-platform graphics programming system at the moment. It's in the process of being replaced by something called Vulkan, which is an incompatible successor to it. OpenGL has been around since the 80s, and a lot of the developers figured it was time to go and develop something new, so that's where Vulkan's coming. It's coming from the same consortium that puts out OpenGL. It says it has a DirectX 11.1 plus feature set. Now DirectX is a Microsoft specific technology, and I don't think they've implemented DirectX. I suspect by a feature set here they mean that the features that you will find in DirectX 11.1 have been implemented such that you can run them on our system. So you'll find all your favorite features here. that's kind of important for game developers in a way, because if they're going to release for Xbox One and PlayStation 4 and PC, it's nice if they work kind of similar. And Xbox One and PC, like with Windows, are both going to have DirectX available. And so Sony wants to make it easy for them to take their game onto PS4. Okay, so then it's got some PlayStation-specific graphics primitives. And I was trying to find any kind of information about these, and it appears you have to be a licensed PlayStation developer to figure out what they are. Sorry, I'm not. So anyway, okay. Now the GPU on here, though, is related to a Radeon, like AMD/ATI's GPU lineup. I say related to because it's not any particular Radeon model. It's a processor that was developed in collaboration between Sony and ATI, which probably means that Sony had some features they wanted changed, didn't want some included, wanted some other stuff. And so they got their own graphics primitives to address the stuff that they've done to their Radeon chip that's not the same as any other Radeon chip. It doesn't carry the Radeon branding. So they got their own graphics primitives on here. Now, I put this is really important on PS3. Well, PlayStation 3 used a cell processing architecture. It was completely different. And so the PlayStation-specific stuff was going to be most of the processing on PS3. Not so on PS4. It's basically a computer in a box. Now, there's this trajectory of consoles merging into being a PC in a box. And so, I don't know if this will continue on to PlayStation 5. I'm assuming Sony has thought about PlayStation 5. But
It does take quite a while to develop these things.
right, and PlayStation 4 is still a good seller. So, yeah, I don't know what they're going to do. Maybe just Vulkan, who knows. That would make a lot of sense. Okay, and they're using this Clang LLVM compiler stack, and they had a lot of reasons they gave for it. Let's talk about compilers a minute here. So, GCC, GNU Compiler Collection, is absolutely dominant on any of the kind of Linux-style platforms, except OS X. And part of the reason for this is that it tends to actually run programs faster. So I did a little test on Software yesterday. Oh, I didn't mean to do that exactly. Okay, I think I actually ran these somewhere else. But, I ran them on Nimrod, even though they were located in my software. So I don't know where I did the test, wherever that counts. Okay, so I got this fib.c thing. I've run this before for benchmarks a bunch of times. Fib_c is an optimized version that was built with GCC. And so running it on Nimrod here, I'm getting a time 0.349, and that's pretty consistent, 348. I actually get a better time if iSoftware is partially under load because it ramps the processors up to a higher frequency. And here we got a little bit of a delay. They're idling at like 1200 megahertz, and they got to pop out before making some serious progress. Okay, I should disable that sometime, but I'm worried it would require more cooling, and that would make my office louder and hotter. Anyway, so let's build it with LLVM and Clang. That was easy. That was called? Called A.out. So if we ls here and we Clang fib.c, you can see A.out appeared. So this is rather recognizable for somebody who's been using GCC. Okay, now it ran really slow. Well, let's think about that. If we ran GCC on it without the optimizer, it would run slow, right? Okay. Well, in GCC, we say -03, and that turns on the optimizer. Oh, well, we do that when we build it. Okay. Hey, look at that. It's a, whoa, loopy. Okay, that was pretty consistently around 0.04 or whatever. Okay, incidentally, there's another optimization flag for Clang, and it's kind of secret. Oh, it's not, it's in the man page, called OFast. And if you do OFast, it doesn't necessarily adhere to the C standard completely, but it also appears to slow it down. So I didn't find that super interesting.
It's not super fast.
If we look at man Clang, you can see that a lot of this stuff is just kind of the same. For example, right down here, remember we've been specifying -std equals like C99 on GCC? Well, here's our exact same option. In fact, this is so similar that for the most part, using Clang is as simple as changing your makefile to use Clang instead of GCC. So that's kind of cool. Okay, so anyway, it's available. But yeah, like I said, I did a little test, and GCC was faster, and I looked online, and the general consensus is that GCC is a little bit faster. Not a lot. We weren't a lot there. We were like 10%. But just a little bit. Unless OpenMP is involved. I don't remember, I probably showed you guys OpenMP. Let me remind you what we mean exactly here. If we go to Satra, and I have this function Pixart.cpp that I ran forever one day, 1 month. Yeah, 1 month. Maybe longer than 1 month. And we can say here, Pragma, OpenMP, parallel sections. And so these two sections here don't depend on each other. Go ahead and run them both at once. That's how OpenMP works. It's really kind of a simple threading model. It's kind of cool, really. Hey, you do these both at the same time? Off it goes. Okay, when OpenMP is involved, GCC is apparently a lot faster. And so there's a little bit of a performance disadvantage there. Yeah, so question, why did they choose LLVM if it's slightly slower? Well, it builds much faster. They had an example that it was taken, this thing that takes 25 minutes to build on GCC for the compilation part, not including linking. And with Clang, it was like 1.5 minutes or something. So it builds faster. That's cool. Saves some time. Better errors and warnings, apparently. So that's interesting. So if we Clang, does it have any warnings? Oh, I don't have Clang on here. Okay, fine. If we have a program that doesn't work.
I'd say that one's debatable.
What?
With Clang, having better errors and warnings.
Is that
Oh, really?
a March
Okay.
virus, not PY?
The what?
Yeah.
What's March
Oh,
virus?
that's a virus.
It's a fun one. It just propagates really
Yeah.
well over the network.
Oh.
Yeah, it's from a security class. We wrote a virus one day. A Linux virus.
Was that last semester we did that, or?
That was
Yeah.
spring.
Oh, yeah, I remember that.
Oh, okay.
Yeah, it's one where it uses SSH to, well, it uses your SSH file to connect to those machines and make a copy of itself and then write itself again.
Yeah.
And so it
It's
just
a good virus.
propagates.
Okay, so you said it's debatable. Sony thought they had better error messages. Static analysis, they mentioned this. I found a slideshow from Sony explaining why they like this. This is my summary of it. And yeah, the static analysis they thought was a good thing. And then finally they mentioned a trajectory behind this one. Like GCC is kind of where it's at, you know? GCC has been developed for a long time. There's not a lot of new and exciting features getting added to GCC these days. And LLVM is actually developing. They got cool ideas, like the static analysis, for example. And so it's improving. When they make one of these consoles, they're kind of locking themselves into a system of tools and whatnot for that generation. You know, they could change it. They could say, okay, well, we're going to release a patch for the PS4, and instead of Orbis OS, it's going to run a different operating system that we wrote ourselves, and the development tools are going to change, and you're going to have to rewrite all the games and redistribute them. But they're not going to do that. They could potentially say, well, we're going to change the standard tool. We were using LLVM, and we decided to switch to GCC, and so everybody's developing for PS4 needs to go and change compilers. And you know, they could do that. It's just, it's not a very popular thing to do. It's a little bit locked in. So they want one that they think is on its way up and improving, so that when the PS4 has been around a couple of years, developers are still happy with the tools, and the tools are improving, and hey, maybe the speed gap's going away too. Could be. So they also had a note, though. Apparently, LLVM doesn't have a way to not optimize one function, and they think it would be really cool if they could do that, because when they're trying to debug their game, and optimized code is terrible to debug because none of the line numbers match up. And so when you find a bug, it's not on the line that it doesn't know the line. So that makes it a hassle. And if you can say, well, I think my bug's in this function, I'm going to like not optimize this function, leave the rest of it optimized so it's all realistic and just like it normally is, and see what's wrong with this function. That'd be kind of cool. But I won't do it. LLVM won't do it. Oh, and one other note. On PlayStation 4, they have a minimum optimization level of O2, and the game won't run on the PS4 if you don't have at least O2 optimization enabled when it's built. Just in case you wanted to know. Okay, so that's a summary of that in compilers and systems and memory. And so that's the history of memory and static analysis. Any questions? Everybody want a PS4 to develop on now?
A lot better than an Xbox.
It runs Orbis. That's kind of cool.
Actually, heard of video game development, like working at a game developing company is usually not very fun.
Yeah, I don't
Isn't
know.
as fun as people think it is.
Graphics is terrible.
BSD encourages slavery. So that's.
Well, I'm sure about the bsds.wordpress.com is a reliable source.
Okay, so I guess there are some problems with it. But other than that, it's probably a good operating system. Okay, I'm all done.
Hate is gonna hate.
You open it up and it's Malaysian children using circuits.